The do while statement. A do while statement is like a while statement, but the condition is tested after the statement body completes. Regardless of the value of the condition, we execute the loop at least once. Okay. A do while ends with a semicolon after the parenthesized condition. Okay. In a do statement, in a do, statement is executed before condition is evaluated. Condition cannot be empty. If condition evaluates as false, then the loop terminates, otherwise the loop is repeated. Variables used in condition must be defined outside of the body of the do while. Right. This is important. This part is specifically important. Okay. So we can write a program that indefinitely does sums using a do while. Okay. So repeatedly ask the user for a pair of numbers. So we have this, we have 2, we ask, then we submit. Okay. Not empty. The loop starts by prompting the user for 2 numbers. It then prints their sum and then asks whether the user wishes to do another sum. Condition checks. Okay. Condition checks and more. Okay. Yes or no. So the condition checks the user gave a response. If not, or if the input starts with an n, the loop is exited, otherwise the loop is repeated. Then we have because the condition is not evaluated until after the statement of block is executed, the do while loop does not allow variable definition inside the condition. That is why. If you could define variables in the condition, then use any of the variable, then any of the variable would happen before the variable was, then any use of the variable would happen before the variable was defined, which is not right. Okay. Okay, then explain each of the following loops. So we have do I we correct any problems. Can I have pencil size? Okay. And here. Okay. Do while must not define. Okay. Must not declare and must not declare in condition. Again, we have do while and I will get response while I will. Okay. I think this is correct. Correct any problems you detect. Okay. Okay, so do. And we have this. Okay, so we declare, which gets reassigned again. I think this loop is correct. Looks correct to me. Let's get a second opinion. Right. Let's see. Correct. Any problems? Correct problems if any. Problems if any. Okay. I think do block is created, then we define a variable, and yeah. The problem is scope issue. Uh, right. I don't think having a scope while Cn. Okay, Cn, right, Cn, okay. Ival, and Ival, okay. So, original code, the variable ival is declared. This means the scope is limited to only that block. When the program execution reaches ival condition, the ival variable no longer exists. Okay, okay. Declaration, okay. Because the condition is not evaluated until after the statement or block is executed. Variable definition inside. Okay, variables used in condition must be defined outside the body of the do while. Right. Okay, so that is the problem. Okay. So, okay. The variables used in condition so this is also a problem then, is it? The variables used in condition must be defined outside the body of do while. Okay, Cn, does there exist a single Cn? Okay, I am not sure about this one. Okay, so let's try this out. Exercise 5.44. Section 5.44, and this is exercise. Okay. Okay, let's make the program. Okay, so I have this, right? Okay, so we take the input v1 v2, then we check if Cn. Okay. If I think Cn is global, right? There is only one object, so its value is set Cn. Let's go cout, and we do okay. So let's try this. While okay, my bad. Okay, so I go 5 2, right, 5 and 2, then if I go Z. Okay, so it's simply okay. So since there is only one put string, hence it is global and Any changes are reflected everywhere. Okay, so this is also correct. Okay. Write a program that uses a do while loop to repeatedly request two string from the user and report which string is less than the other. Okay, that is like into that. So, okay, we'll also be using string. So we will do s1 s2, then we prompt the user, right, enter two strings, okay, then we go if s1 s2, then we can okay, then we can print s s1 less than s2, so if s1 is less, okay, we'll go if s1 is greater, then print s1, or print s2. Go biggest string is this, and then we'll check while cn as usual. Okay. Yes, only one input stream has its global. Okay. There's only one standard input stream. Okay. So this is cn, right? Okay. Okay. Oh. Okay. Shivang. Okay. Huh. Okay, then we say COA and CN. TOC and CD. Okay. Then we have jump statements. Jump statements interrupt the flow of execution. C++ offers 4 jumps: break, continue, and go to, which we cover in the chapter, and return statement, which we'll discuss here. Okay, the break statement. A break statement terminates the nearest enclosing while, do while, for, or switch statement. Execution resumes at the statement immediately following the terminated statement. Okay. A break can appear only within an iteration statement or switch statement, including inside statements or blocks nested inside such loops. A break affects only the nearest enclosing loop or switch. Okay, so a break affects. Okay, so then we have a string buff. We read it as string. Yeah. Okay, cn and okay, so the and not s1 dot empty right, s1 dot empty, right, and s2 dot empty, right, okay, better. Okay, so we have this process up to the first blank. Okay, just a second. All right, now, so we go process up to first blank, where it is not blank, break. Okay, so break one, this leaves the for loop, this leaves the transfer control here. So break and transfer remaining dash processing break leaves the switch. Okay, then case, and then this is the end switch, end of switch, break number 2, transfer controls here, then end while. Okay, the break labeled 1 terminates a for loop that follows the hyphen case label. It does not terminate the enclosing switch statement, and in fact does not even terminate the processing for the current case. Processing continues with the first statement following the for, which might be additional code to handle a hyphen or the break that completes that section. The break labeled 2 terminates the switch but does not terminate the enclosing while loop. Okay, processing continues after that break by executing the condition in the while. Okay. And we have this section: write a program to read a sequence of strings from the standard input until either the same word occurs twice in succession or all the words have been read. Okay. Use a while loop to read a text one word at a time. Use the break statement to terminate the loop if a word occurs twice in succession, and print the word if it occurs twice in succession, or else print a message saying no word was repeated. Okay, this is easy. Okay, so we can make a new section, say 5.5.1, and this is exercise 5.2. Okay. Okay, so we have while, let's create oh yeah, I can read it directly into the new string. Let's try, no? Say string, a new string, creating a new I don't think so this is how this works, but doesn't matter. We'll try. We will give it a try. Yep. Okay, so yeah, declaration. I cannot declare, I can define, but this is right associative, right? So it won't work that way, right? So I would have to declare this as temp temp, and then let's declare current. Okay, so we go if temp equals current, break. Okay, else current equals temp. Okay, so so I want say say was repeated, right? Question: print the word if it occurs. Was repeated. Yeah, I can. Yeah, but how would I know outside the loop okay, we're checking this condition if it evaluates to okay, so I'll say see we can see out, yeah, but that would this is not good. Okay. So we'll go bool repeated equals let's say true or false, and we set repeated equals false. Repeated equals true. Okay. If repeated, then I can print this, else can print, what do I have to print? No word was repeated. Okay, so say Shivang, Shane, C++, great. So this is also done. The continue statement. A continue statement terminates the current iteration of the nearest enclosing loop and immediately begins the next iteration. A continue can appear only in for, while, or do while loop, including inside statements or blocks nested inside such loops. Like the break statement, a continue inside a nested loop affects only the nearest enclosing loop. Unlike a break, a continue may appear inside a switch. Unlike a break, a continue may appear inside a switch only if that switch is embedded inside an iterative statement. Right. Okay. A continue interrupts the current iteration. Execution stays inside the loop. In the case of a while or a do while, execution continues by evaluating the condition. Okay. In traditional for loop, execution continues at the expression. Okay. In a traditional for loop, execution continues at the expression inside the for header. Expression for show me for mirror for, okay, so for I think expression itself is the condition, right? Expression itself, yep. Okay, expression. Okay, so expression. Okay, expression, that is the updation. Okay, so in traditional for, execution continues at the expression inside the for header. In a range for execution continues by initializing the control variable from the next element in the sequence. Okay. Okay, so it goes from this, this, and this. Okay. And then, for example, the following loop reads the standard input one word at a time. Only words that begin with an underscore will be processed. For any other value, we terminate the current iteration and get the next input. Okay, get another input, get another input. The input starts with an underscore process. Okay. Revise the program. Revise the program for the exercise 5.5.1 so that it looks for only duplicated words that start with an uppercase letter. Okay. Duplicate words that start with an uppercase letter. And to create 5. Okay, if those are not upper, then we simply terminate the right. CC type string. Okay, so we have while loop. Yeah. Read in temp, then if is upper. I think there should be a function in C. Okay. C type functions. Asylum to upper is upper, right? Okay, is upper. Is upper. Okay, if the first letter, right? That looks for only for duplicated words that start with an uppercase letter. Okay. If is upper, temp of 0. If is upper, then we can check. Okay, we would need this as well. Then we would check. Okay, so is upper, yeah, right, correct, this is correct, the formula stays the same. Okay, current equals temp, and then in the end we write this. Although I should always add that is a neat feature. So let's say if it's upper and current, else say this. Okay, so it's a shame. I go sure. I didn't compare then I go sure. And then if I go shame, I go sure. Ah, but okay. Ooh, okay. So that is where's upper. Okay, how do I know from the exercise so that it looks only for duplicated words if that word starts with an uppercase? So I can flip. I think I can flip, right? Yeah, I can flip these so that okay, let's remove this. Let's remove this. Let's get here. Here. Okay, if they are equal. Okay, and if they are equal and if they are equal and then if they are equal and then if the letter is upper. Okay, so I'll go Shiva, I'll go Shiva, I'll go Shiva, and I'll go Shiva. Okay, clear. Alright. Okay, the go to statement. The go to statement provides an unconditional jump from the go to another statement in the same function. Programs should not use go tos. Go tos make programs hard to understand and hard to modify. Right. Okay, syntactic form of go to statement is this go to label. Where label is an identifier that identifies a statement. A label statement is any statement that is preceded by an identifier by a colon, followed by a colon. Okay. Label identifiers are independent of names used for variables and other identifiers. Hence, a label may have the same identifier as any other entity in the program without interfering with the other uses of that identifier. The goto and the label statements to which it transfers control must be in the same function. Okay. As with the switch statement, a goto cannot transfer controls from a point where an initialized variable is out of the scope to a point where variable is in scope. Okay. Error, goto bypasses an initialized variable definition. Okay, the code. Right. A jump backward over an already executed definition is okay. Jumping back to a point before a variable is defined destroys the variable and constructs it again. Okay. Go to begin. Okay, right. Okay. His size is destroyed when go to executes. It is defined and initialized anew when control passes back through its definition after the jump back to begin. Okay. The last example in this section. Okay. The last example in the section that jumped back to begin could be better written using a loop. Rewrite the code to eliminate the go to. Okay. Size less than. Okay, we can do that. We can. Sorry. This is exercise. I don't think I really need to write. Okay. Let's remove directory. Section 5.5 dot 10. Okay. I can write the code here. There we go. Okay. So it wants file size. Okay. We go with int size. The size is less than or equals to 0. Int size, right? Initialize at 0, then we say while size, okay, size is less than equals to 0. We can go size equals, this is get size. So it will simply loop. Size is less than or equals to 0. Okay, try blocks and exception handling. Exceptions are runtime anomaly. Exceptions are runtime anomalies, such as losing a database connection or encountering unexpected input that exists outside the normal functioning of a program. Dealing with anomalous anomalous dealing with anomalous behavior can be one of the most difficult parts of designing any system. Okay. Exception handling is generally used when one part of a program detects a problem that it cannot resolve, and the problem is such that the detecting part of the program cannot continue. In such cases, the detecting part needs a way to signal that something happened and that it cannot continue. Moreover, the detecting part needs a way to signal the problem without knowing what part of the program will deal with the exceptional condition. Having signaled what happened, the detecting part stops processing. A program that contains code that might raise an exception usually has another part to handle whatever happened. For example, if the problem is invalid input, the handling part might ask the user to provide correct input. If the database was lost, the handling part might alert an operator. Okay. Okay, hold up. Exception handling supports this cooperation between the detecting and handling parts of a program. In C++, exception handling involves throw expressions. Throw expressions which the detecting part uses to indicate that it encountered something it can't handle. We say that a throw raises an exception. Okay. We throw expressions which the detecting part uses to indicate that it encountered something it can't handle. We say that a throw raises an exception. Okay. Try blocks, which the handling part uses to deal with an exception. A try block starts with the keyword try and ends with one or more catch clauses. Exceptions thrown from code executed inside a try block are usually handled by one of the catch clauses. Because they handle the exception, catch clauses are also known as exception handlers. Alright. A set of exception classes that are used to pass information about what happened between a throw and then a set of exception classes that set of exception classes that are used to pass information about what happened between a throw and an associated catch. About happened. What happened? Okay. In the remainder of this section, we'll introduce these three components of exception handling. We'll also have more to say about them again. Okay. A throw expression. The detecting part of a program uses a throw expression to raise an exception. A throw consists of the keyword throw followed by an expression. Okay. So the detecting part of a program uses a throw expression to raise an exception. A throw consists of the keyword throw followed by an expression. The type of expression determines what kind of exception is thrown. Okay, a throw expression is usually followed by a semicolon, making it into an expression statement. Okay, so as a simple example, recall the program that added two objects of type sales item. Okay, come back really quick. Okay, so as a simple example, recall the program in this that added two objects of type sales item. The program checked whether the records it read refer to the same book. If not, it printed a message and exited. Okay, so let's check again. In a more realistic program, the part that adds the object might be separated from the part that manages the interaction with the user. Okay. In this case, we might rewrite the test to throw an exception rather than returning an error indicator. Okay, so throw runtime error. Data must refer to same ISBN. In this code, if the ISBNs differ, we throw an exception that is an object of type runtime error. Throwing an exception terminates the current function and transfers control to a handler that will know how to handle the error. Okay, the type runtime error is one of the standard library exception types and defined in the std except header. We'll have more to say about these types here. We must initialize a runtime error by giving it a string or a C style character string. Okay. That string provides additional information about the problem. Okay, the try block. So the general form of a try block is try, program statements, catch, exception declaration, handle statements, exception declaration, handle statement. A try block begins with the keyword try, followed by a block, which as usual is a sequence of statements enclosed in a curly braces. Following the try block is a list of one or more catch clauses. Okay. Following the try block is a list of one or more catch clauses. A catch consists of three parts: the keyword catch, the declaration of a possibly unnamed object within parentheses referred to as an exception declaration, and a block. When a catch is selected to handle an exception, the associated block is executed. Once the catch finishes, execution continues with the statements immediately following the last catch clause. Immediately following the last catch clause of the try block. The program statements inside the try constitute the normal logic of the program. Like any other block, they contain any C++ statement, including declarations. As with any block, variables declared inside the try block are inaccessible outside the block. In particular, they are not accessible to the catch clauses. Okay. Writing a handler. In the preceding example, we used a throw to avoid adding two sales items Okay, in the preceding example, we used a throw to avoid adding two sales items that represented different books. We imagined that the part of the program that added two sales items was separate from the part that communicated with the user. The part that interacts with the user might contain code, something like the following to handle the exception that was thrown. Okay, so we try execute code that will add two sales item if okay, error what? If the addition fails, the code throws in runtime exception. Okay, then we have remind the user that ISPNs. Okay, so what? Try again, and then we can go. The ordinary logic of the program that manages the interaction with the user appears inside the try block. This part of the program is wrapped inside a try because it might throw an exception of the type runtime error. Right. Then we have this try block has a single catch clause which handles exceptions of the type runtime error. The statements in the block following the catch are executed if the code inside the try block runs through the runtime error. Okay. The statements in the block the statements in the block following the catch are executed if the code inside the try block throws a runtime error. Our catch handles the our catch handles the error by printing a message and asking the user to indicate whether to continue. If if the user enters N, the break is executed and we exit the while. Otherwise, execution falls through to the closing brace of the while, which transfers control back to the while condition for the next iteration. Okay. The prompt to the user prints the return from error what. We know that error has a type runtime error, so we can infer that what is a member function of the runtime error class. Each of the library exception classes define a member function named what. These functions can take no arguments and return these function takes no argument and return a C style character string. Okay. The what member of runtime error returns a copy of the string used to initialize the particular object. Okay. If the code described in the previous section threw an exception, then the catch would print this. Okay. Functions are exited during the search for a handler. In complicated systems, the execution path of a program may pass through multiple try blocks before encountering code that throws an exception. For example, a try block might call a function that contains a try, which calls another function with its own try, and so on. Okay. The search for a handler reverses the call chain. When an exception is thrown, the function that threw the exception is searched first. If no matching catch is found, that function terminates. The function that called the one that threw is searched next. Okay, I got it. Okay, so it is layer by layer. Can I draw any shapes? No, no shapes. Okay, that's okay. Okay. So let's. I should think. Let's say this called this called this. Let's say this is F1, this is F2, and this is F3. Okay, so let's say we have a try here and try throws. Okay, so search, search, and then search. Okay, the function that called, the one that threw, is searched next. If no handler is found, the function also exits. The function's caller is searched next, and so on. Back up the execution path until a catch of an appropriate type is found. Okay. If no appropriate catch is found, execution is transferred to a library function named terminate. The behavior of that function is system dependent, but is guaranteed to stop further execution of the program. Okay. Exceptions that occur in programs that do not define any try blocks are handled in the same manner. Okay, okay. After all, if there are no try blocks, there can be no handlers. If a program has no try block and an exception occurs, then terminate is called and the program is right. Okay, writing exception safe code is hard. It is important to realize that exceptions interrupt the normal flow of a program. At the point where the exception occurs, some of the computations that the caller requested may have been done, while others remain undone. In general, bypassing part of the program might mean that an object is left in an invalid or incomplete state, or that a resource is not freed, and so on. Progr- Programs that properly clean up during exception handling are said to be exception safe. Writing exception safe code is surprisingly hard and largely beyond the scope of this language prime. Okay. Some programs use exceptions simply to terminate the program when an exceptional condition occurs. Such programs generally don't Such programs generally don't worry about exception safety. Programs that do handle exceptions and continue processing generally must be constantly aware of whether an exception might occur and what the program must do to ensure that objects are valid, that resources don't leak, and that program is restored to an appropriate state. Okay. So we will occasionally point out particularly common techniques used to promote exception safety. However, readers whose program require robust exception handling should be aware that techniques we cover are insufficient by themselves to achieve. This is hard. Okay. We have standard exceptions. The C++ library defines several classes that it uses to report problems encountered in the functions in the standard library. These exceptions these exception classes are also intended to be used in the programs we write. Okay. These classes are defined in four headers. Exception header defines the most general kind of exception class named exception. It communicates only that an exception occurred but provides no additional information. Stud except header defines several general purpose exception classes which are listed here. Okay, then the new header defines bad alloc exception type, which we cover this, and the type info header defines a bad cast exception, which we cover here. Okay, so these are exception runtime error, range error, overflow error, underflow error, logic error, domain error, and then we have invalid argument, length error, and out of range error, runtime error, result generated outside the range of values that are meaningful. Okay. So this out of range use a value outside the value string. Okay. Result generated. I don't. It's not. It's just a table here. Alright, so the library exception classes have only a few operations. We can create, copy and assign objects of any of the exception types. We can only default initialize exception, bad luck and bad cast objects. It is not possible to provide an initializer for objects of these exception types. The other exception types have the opposite behavior. We can initialize those objects from either a string or a C-style string, but we cannot default initialize them. When we create objects of any of these exception types, we must supply an initializer. Okay, that initializer is used to provide additional information about the error that occurred. The exception types define only a single operation named what. That function takes no argument and return a const char that points to a C-style character string. The purpose of the C-style character string is to provide some sort of textual description of the exception thrown. Okay, the contents of the C-style string that what returns depends on the type of exception object. For the types that takes a string initializer, the what function returns a string. For the types that for the types other, the value of the string returns varies by compiler. Okay, so this is end of chapter.